today we're going to take a look at the first two examples of 6-2, radicals and rational exponents. So what we're going to do is we're going to learn a few more exponent rules properties, and we're going to simplify them. Let's take a look at what a radical symbol is. So if we take a look here, a radical expression is an expression that includes, well, a radical symbol. So what we call the square root key most of the time. So radicals and powers are actually inverses of each other. So a power looks like this. 2 cubed, which is 2 times 2 times 2, is 8. Now a radical would look like this. And this is telling me that I need to find a number multiplied by itself 3 times that equals 8. So my answer here is 2. So powers and radicals are actually inverses of each other. Now, I want to take a look at what a radical is. So, as you recall, this whole entire thing is actually called a radical. Our little symbol here is, well, shockingly enough, the radical symbol. Our 8 here is what we call the radicand. A radicand, and then this 3 is the index. Now we're going to be spending a lot of time talking about that index today. So let's take a look at finding the answer to some radicals. So here I've got the cubed root of 27. So what number times itself 3 times is 27? Well, that's 3. Now I've got the 4th root of 16. So what number multiplied by itself 4 times is 16? Well, actually, that answer is 2. 2 times 2 times 2 times 2 is 16. But it's also negative 2. Negative 2 times negative 2 times negative 2 times negative 2 is 16. Now, if I look here at the cubed root of negative 8, what number multiplied by itself 3 times is negative 8? Well, that is negative 2. Negative 2 times negative 2 times negative 2. I have an odd number of negatives, so my answer is negative. Now I can think of this as the opposite of the square root of 25. So the square root of 25 is 5. And the opposite of that is negative 5. Now, I'm looking here for the square root of negative 25. If there's no index, that declares that this is actually a square root. So what number multiplied by itself twice is going to give us negative 25? Well, the answer there is no real numbers. Be careful here. The answer is not no solution, because believe it or not, there are imaginary numbers. Yes, there are imaginary numbers in math. But we're not going to get to that until Algebra 2 or maybe even trig. So for now, our answer here is no real numbers. Well, when we take a look at some radicals here, remember how we said the square root of, or the 4th root of 16 was positive or negative 16? Well, think about it this way. So if we have even roots, our answer is going to be positive or negative. Why is that? Well, if I have the square root of 4, I can do 2 times 2 or negative 2 times negative 2. Either way, those answers are 4. So if I have an even index, my answer is going to be positive or negative. If I have an odd root or an odd index, my answer is going to be positive or negative, depending on what my radicand is. So if I had the cubed root of 27, well, the only way to do that is 3 times 3 times 3, that's 27. If I did negative 3 times negative 3 times negative 3, that's going to give me negative 27. So the cubed root of negative 27 is going to be negative 3. All right, so let's take a look down here at example 1. Find the indicated real nth root of A. So n is my index, A is my radicand. So I'm looking at this here. So what is the cubed root of negative 16? Well, whoops, negative 64. Sorry about that. Negative 64 is negative 4. Now, believe it or not, I could actually rewrite this as an exponent. So I can take the nth root of a and rewrite that as a to the 1 over n. Now I'm going to come back to that in just a second here. I'm kind of jumping ahead here. But I can also rewrite this just like this. Now, if I take a look here, I've got the square root of 81, which is plus or minus 9. Remember, 9 times 9 is 81, but so is negative 9 times negative 9. Now, I could also do 81 to the half. Think about it, it's almost kind of like there's a 1 right there. So again, plus or minus 9. So I can rewrite those using exponents. So here's what I want you to do. Go ahead, try these, hit pause. When you're done, come on back. All right, the cubed root negative 125 is negative 5. Rewrite the sixth root of 64, plus or minus 2, even root. Cubed root negative 64, well, that's negative 4. And then right here, we have the square root of 81, which we just did these last two together, plus or minus 9. So just a second ago, you saw me turn these into fractions. Well, I want to take a step back to fractions for a second. If I had 4/5 as a fraction, I could rewrite this as 1/5 times 4. Okay? If I had 2/3, I could rewrite that as 1/3 times 2. So where is that coming from? Well, what we're actually doing here is I'm kind of splitting this up a little bit and showing you how we can use these fractions to help us write radicals using exponential expression. So if you think about it, if I have the square root of a, right down here, that's the same as saying a to the 1/2 because I'm taking this to the first power. Now it's going to come back in just a second. So my 2 came from the square root. Now it's a little bit hard to see, so I apologize. Let me rewrite this here. So we kind of have our little invisible numbers here. So this is squared, or this is to the square root. And I kind of have an exponent here of 1. Anytime I have a number to the exponent of 1, it's always itself. So here is where the 1 comes from. Here is where the 2 comes from. So this is where we end up with the nth root of a equals a to the 1 over nth power. Now you might be thinking, what the heck? I need a little bit more of an example there. Okay, so let's take this one step further. So if I have a to the m over n, and now you've seen those, believe it or not, already. What I'm going to do is I'm going to rewrite these. So I've got, this is my root, and this here is my exponent, and by using our exponent rules, I can pull these out to look just like this. So what does that mean? Well, if I have 16 to the 4th power, or the 1/4 power, here's my root, my radicand, and my exponent. Now, do I really need to take something to the power of 1? No. So I can rewrite it just like this, because anything to the first power is always itself. So the 4th root of 16 here is 2. Now, there's a little typo here, so I apologize. So I have the 4th root of negative 16, and what number multiplied by itself 4 times is going to give me a negative number? Not a real number. So my answer here is not a real number. So let's split these up a little bit more and kind of give you a better idea as to what this looks like. Now, you need to be really careful here. Make sure you watch the roots for odd or even numbers. So I have the cube root of 64, which can be rewritten as 64 to the 1/3 power, which is 4. Now, 36 square, the cubed root, oh my gosh, the square root of 36 can be written as 36 to the half, which would be plus or minus 6, because I have an even root. Remember, if there's no number in the index, that is a 2. Talking about the square root here. So the 5th root of 32 can be written as 32 to the 1/5, which is going to give me 2. Odd index, just a positive answer here. Now I've got an odd index here. My radican's negative, so that means my answer here is going to be negative. Now when I rewrite this, remember to put that number in the parentheses. So I have negative 125 to the 3rd, which is going to give me negative 5th. Now that I have the rational exponent, what does that look like in the radical? Well, I've got my square here, so that's 2. My radicand is negative 25 and to the 1st power, and the square root of negative 25 is not a real number. I'm going to be really picky with this one. Make sure you don't write no solution, because technically there is. All right, so now here I've got the cubed root of negative 8 to the 1st power, and the cubed root of negative 8 is negative 2. All right, everybody, nice job. Have a great day.